Okay, so chapter 3a, number 15, we're told that AB and CD are parallel, and also that the AD and BC, the top and bottom, are parallel, and we want to show that A and C have to be the same. Okay, so we're given parallel lines here, and so whenever you're given parallel lines, you should start thinking, well, what do parallel lines then turn into? What do they result in? And so over here, I've listed off all of our parallel line reasons that we've come up with for this chapter. Okay, now in this case, we're looking at the fact that we have parallel lines already. We're not trying to get parallel lines. So I'm only going to focus on these ones up here. These are the important ones, the ones where you already have parallel lines. Right? So I'm not even going to bother with these. Okay. So now let's make a chart for our proof. Statements, reasons. Okay, so first let's start with just one of the givens. Let's start with AB parallel to CD given. Okay, so that's this one here and this one here are parallel. Okay, well, parallel lines give me all of these things right here. Okay, so what I'm going to do is I'm going to emphasize this one transversal right here. And the angles that are inside this shape that I can use are going to be this one right here and this one right here. And if I move this off to the side, those are alternate interior angles. Right, so let me put it back here for a second. And I'm going to say, whoops, let me move that just into place. So I'm going to say that, I'll just redraw this. Angle ABD here is the same as angle BDC right here. And in case you're not seeing it, remember these are already parallel, and here's my Z shape. And if you still can't see it, extend those lines, right? There it is, right? Alternate interior angles. So ABD and BDC. Angle ABD is the same as angle BDC because parallel lines give me alternate interior angles that are congruent. Okay, so now I have this one and this one match up. Okay, well let's look at our next given. Our next given is AD is parallel to BC. Right, I'm actually going to chunk these two steps together. So AD parallel to BC, that's going to be the bottom and the top. Right, so now these guys are parallel. And if I look at this transversal here, right, if I move this to the side, right, let me get rid of these for a second. That's part of this picture. This angle here and this angle here should be the same because they're also alternate interior angles. And I know that the top and bottom here are parallel. And here's my Z shape. So if I put this back, right there, you can see that it's CBD and ADB are the two angles that I just highlighted down here. Right? So I'm going to list those off. Angles CBD and ADB are the same. Oh, I forgot to put right given here. So this reason, again, they're alternate interior angles. So parallel lines give me alternate interior. Okay, so let me erase some of these things right now. So right now that's what I have. My goal is to prove that this angle here is the same as this angle here. And if you think about it, well, look at what I've done in steps 2 and 4. I've matched up two angles of this triangle with two angles of this triangle. So I can actually jump to my last step now. Angle A is congruent to angle C because I have two angles of one triangle that are the same as two angles of another triangle, So the third angles have to be the same too.